Morning, dear students. Let us talk about strain displacement relation as a part of finite element method content. So, wherein you need the prerequisite knowledge of theory of elasticity. So, this topic is actually from theory of elasticity, wherein we'll be using in finite element method. Okay. Yeah. So, if you talk about displacement, so it has got three components which we will represent like u, v, w. So u being displacement in x direction, okay, v being displacement in y direction, okay, w, z direction. So three global directions x, y, z. So these are the representation of displacement in those three directions. Coming to the strain, so you have studied the content strain in strength of materials, where we have represented the strain with epsilon. So this also has got the components. So you know the strain components are like epsilon x, y, z. These are the three normal strain components. These are called normal strains. Okay. Shear strains are also there, like gamma xy, yz, zx. So these are shear strains. Okay. So this is something like strain. Okay. Right. So when do you have strain in a body? So that we need to know. Okay. Let us say, for example, I have considered a body which is in plane x, y. Okay. Uh, Let us choose 2 points. Let us say A, B. Okay. This is before you apply the forces on this body. After you apply forces on this body, like some type of forces, so this body is going to deform something like this. Okay. So the point A would have been moved to somewhere, something like this. And point B would have been moved to something like this. So I call this as A dash and B dash. So A displaced to A dash, B displaced to B dash. Okay. Let us say length AB is equal to say L naught. Whereas A dash B dash is equal to, let us say, L1. Okay. So if L naught is equal to L1, means the points which are being displaced, okay, have not been elongated, or the dimensions have not changed. Okay. So this what we call is the rigid body movement. Rigid body. Okay. As if L naught is not equal to L1, means the length of AB is not equal to A dash B dash, then we say the body has got deformed, which means you have strain in the body, because the deformation that is being caused by the loads, okay, the amount of deformation divided by original dimension, we mention it as a strain. So if you say there is strain in the body would have been deformed. Okay. So this is the very basic information regarding what is meant by displacement and what is meant by rigid body moment, what is meant by deformable body, and how you get strain in the body. And coming back to these components, now we need to establish the relation between these displacement components and the strain components. So it is strain displacement relation. Okay, so this is what we need to derive the relation. Okay, so this we'll do in the next session, right? Thank you.